Today we're going to talk about limiting and excess reactants. So far we've done some balanced equations, and those balanced equations shows us exactly how much reactants we need, and that would make a perfect amount of products. But sometimes in the real world we throw things together and we don't really have the exact measurements, and so one of our reactants we're going to have too much of, and that's called the excess reactant. And then one of those reactants is going to run out, and that's called the limiting reactant. So before I get into examples that will really explain it better, we're just going to go through some of the vocab. So our limiting reactant is the reactant that runs out first in a reaction. Now, if we run out of any reactant, we cannot make any more product because part of our reactants are gone. So this reactant limits or determines the amount of product can be made. Once a reactant runs out, the amount of products being made stops, and that's why we call it the limiting reactant. So again, the limiting reactant is what runs out first in a reaction, and it is the one that determines the amount of product that can be made. And so when that one runs out, we still might have some of the other reactant left. So we might have too much, or we might have excess. So our excess reactant is the reactant that's left over after the reaction is complete. It's the one that's in excess. Okay? When we see a limiting reactant problem, it's always going to give the amount of 2 or more reactants. If you only have the amount of 1 reactant, it is not a limiting reactant problem. So in real life, let's see what that looks like. So here's our recipe or our balanced equation, and we're just going to make a cheese sandwich. So we need 2 pieces of bread and 1 piece of cheese, and that equals or yields 1 sandwich. Okay, so here's my 2 pieces of bread, here's my piece of cheese, and here, because I'm not a great artist, is my sandwich, and that's the cheese in between. Okay, so this is my perfect recipe. If I have 2 pieces of bread and 1 piece of cheese, I make 1 sandwich. But we don't always have just 2 pieces of bread. We might have a whole loaf and 1 piece of cheese. Well, then we're going to have extra bread or excess bread, and when we run out of cheese, we can no longer make a cheese sandwich, so the cheese is going to limit if I had a whole loaf of bread and 1 cheese. So let's look at this example, and let's say we start with 2 pieces of bread and 2 pieces of cheese. Okay, so what I'm going to do is I'm going to take my 2 pieces of bread and my 1 piece of cheese, and that is going to make my 1 cheese sandwich. Okay, so now that I've done this, what ran out? Well, we ran out of bread, right? And what do we still have left over? We still have left over 1 piece of cheese left over. And how much did we make? We made 1 sandwich. Okay, so now the stuff that runs out is our limiting reactant. And sometimes it's called reagent, reactant, same thing. And the stuff that's left over is our excess, okay? And we write excess, okay, is our cheese. And so you can see, why did we stop making sandwiches? We stopped making sandwiches because we no longer have any bread. The bread ran out. It's our limiting reactant. It limits the amount of sandwiches that can be made. So our last problem, we had equal number of cheeses and bread. And up here, our bread is the bigger number, but it is the limiting reactant, as I showed you. A lot of people make the mistake of trying to look at these numbers and see which one's bigger or smaller and determine the limiting reactant based on that. I'm just going to show you why this bigger number is actually the one that runs out first. So we're going to now start with 4 breads and 3 cheeses. So I take 2 breads and 1 cheese, and I make my sandwich with my cheese in there. Okay, and then I have another 2 pieces of bread and a cheese, and I make another sandwich. I'm getting really bad at my artistic. work here, okay? And now I have no more bread left. So this is the limiting reactant, even though I have more of it. And this is my excess. And how much do I have left over? I have 1 cheese left over. And I made 2 sandwiches. So again, excess, I have cheese left over. Limiting reactant, it ran out. And that's the reason we couldn't make any more sandwiches. So now we are going to look at a limiting reactant problem. And the problem is if you start with 7 moles of H2 and 4 moles of N2, what's the limiting reactant? What's the excess reactant? And how much ammonia can be made? So basically, and you guys don't have to draw this part. This is just something I'm going to do to show you visually what's going on. But we are going to have N2 plus 3H2 is going to make 2 ammonias. That's balanced. And I'm starting with 7.0 moles of hydrogen and 4.0 moles of nitrogen. Now, normally we start with 1 and we have plenty to react. When I have 2 amounts of a reactant, it could be moles, it could be grams, that shows me I have a limiting reactant problem. So let's look at this visually. The first thing I have here is I have my hydrogens drawn. Notice they're all bonded. 2 hydrogens make 1 hydrogen gas molecule. And my nitrogens have lines to them, and I have 1, 2, 3, 4 of those, and they are all bonded as well. And NH3 takes 1 nitrogen and 3 hydrogens. So let's take that 1 nitrogen and 1, 2, 3 hydrogens. So I have made 1 ammonia. Now I'm going to take another nitrogen and 1, 2, 3. Another nitrogen and 1, 2, 3. Okay, I still have reactants. Another nitrogen, 1, 2, 3 hydrogens. Another nitrogen and 1, 2, 3 hydrogens. Now this is if I had molecules, so I can actually make a little piece more if I'm doing it in moles, because remember, every mole is a sextillion, so there's tons there. So I have 4 point something left, and this is why we have to start doing this mathematically. But visually, you can see right away that my hydrogen is going to run out. So it's going to be my limiting reactant. And my nitrogen, I'm still going to have some left, right? Because I can take 1 and then I can take part of that one and parts of those. And that's because we aren't talking about actual molecules. We're talking about a sextillion of all these little molecules. And what I'm going to do with you is the easiest way to do this. We are just going to run this like it's 2 separate problems. If I have so many moles of nitrogen and plenty of hydrogen, how much can that be produced? Second problem, if I have 7 moles of hydrogen and plenty of nitrogen, how much could be produced? The one that produces the least, that shows us which one runs out. Okay, so here's my initial problem, but I'm going to run it like 2 separate problems. I'm going to run it like that and figure out how much ammonia can be made, and I'm going to run it with hydrogen and figure out how much ammonia can be made. And so our separate problems would be, we start with 7 moles of hydrogen and excess nitrogen, how much ammonia can be made. Okay, so right away it tells us our excess is nitrogen, our limiting is H2, but that's for a single problem. So when I plug that in, I start with 7 moles of hydrogen and plenty of nitrogen, I would make 4.7 moles of ammonia. Now I'm going to run the problem again with nitrogen as my reactant and plenty of hydrogen. Okay, so that would mean my excess is hydrogen and my limiting would be nitrogen. So if I had plenty of hydrogen, how much could 4 moles of nitrogen produce of ammonia? Okay, so I start with my 4 moles, I do my mole to mole ratio, and if I had 4 moles of nitrogen, that could produce 8 moles of ammonia. Okay, and H3. Those go away, I'm left with ammonia. So now, if I put these two separate problems together, I started with one of my reactants, I started with the other one, which one produces the least? Okay, so here is my problem. I just restated it again. Which produced the lowest amount is the one that runs out first. Okay, so hydrogen produced 4.7 moles and nitrogen produced 8 moles. So this one produced the least amount of product. It's going to run out first, which means for the original stoichiometry problem, my limiting is my hydrogen and my excess is my nitrogen. And then I have to use this limiting reactant amount. 4.7 moles of ammonia can be made. So on your little quiz/worksheet, you're going to be given one problem, you're going to solve it, you're going to be given two problems, you're going to solve it, and then I'm going to ask you, if I used that amount for both reactants, what would happen? And you will pick out the lowest amount to be the amount that's made of your product, and whatever reactant made that least amount would be your limiting reactant. Okay, and that's all we're doing. Now, if we went farther, there is another way to look at it. This is not notes anymore. I'm just going to go through and show you how it works. Okay, so here's our same problem. But we started with these two reactants, 7 moles of nitrogen and 3 moles of hydrogen. I can decide, if I have 4 moles of nitrogen, how much hydrogen do I actually need? Okay. Now I can look at this, that's a 1-to-3 ratio, so it's 3 times the amount. And that's what your mole ratio does. 4 moles of nitrogen. How many moles of hydrogen do I actually need? There's my 3-to-1 ratio. And I would need 12 moles of hydrogen. So I would need 12 here. Do I have 12? I do not. I only have 7. Okay, so my hydrogen's going to run out. And that means it's my limiting reactant. And that means this number is the number I use to calculate how much ammonia can be made, just like we did. And I can also use it to calculate how much nitrogen I would need, and then I can figure out how much nitrogen's left in the reaction. But you don't have to do that. I just went through this to show you things we would normally do if we were not virtual.